Hello everyone, today I talk about the experiment of verifying Newton's second law using the electric vibration device. Close of the article, the acceleration is proportional to the force acting on the object and inversely proportional to the mass of the object. My representation have 5 parts. First of all, purpose. In order to account this correlate, we use this experiment to verify the relationship between the acceleration and the force acting on the object and its mass. A and F, A and M, mass of the object. Second is speaking of the problem. To account this clearly, the question posed to students should be: what is the relationship between the acceleration and the force acting on the object and its mass? Yes. Next to presentation. For situation a problem. For a full problem, we need to start with the situation so that the student feel interested in the problem and are ready to take part in solving the problem. The situation is as follows. A car was standing on the floor very smoothly. We push the car stronger. The car accelerates faster, with greater acceleration. We still push as before, but with bigger mass of the car. If the car have good, yes, the car accelerates less. It means acceleration decrease. With the situation, we see that the acceleration of the object depends not only on the force acting on the object, but also on its mass. However, we do not know how changing the acceleration of the object depend on above factor specifically. This situation will create a condition for students to come up with the problem in a natural way. Next, for solution. In order to solve the problem mentioned above, we will have to use the experiment to measure the mass of the object and magnitude of the force acting on it and determine its acceleration. Case 1. Changing the force acting on the system object is mean m mass and constant. Measure respective acceleration to verify. Case 2. Changing the mass of the object when the force acting on the object constant. Measure respective acceleration to study. We will study important parts conducting the solution. 5. Conducting the solution. Case 1. In order to have the object, we use the car. But put on the car the weight and it will be moving in the aluminum track. To acting on the force on object, we use a weight connect to object with a pulley. Take the weight in the car, tie the string to changing the force acting on the object and mass of system object constant. The system, the object have a car and a weight of string. To measure acceleration of system the object, we use the electric vibration device. Acceleration is determined by formula A equal to delta L over 2 T square, where delta L is difference of distance between successive points in paper. T equal to 0.02 second is a period of vibration device. We do experiment with different force and write in the data table. Data table have F and R in 1 meter, 2 meter, and 3 meter. Yes, so in conclusion, are proportional to the force acting on the object. We have conclusion A proportional, F okay. We consider K2 is K1 and K2 in order to changing the mass of system object, but the force is constant. We set the experiment as K1 and add the weight on the car to weight of system object and measure acceleration as K2. Repeat the experiment and so we have the data table. Data table have M and A in 1 meter, 2 meter, and 3 meter. So conclusion, A inversely proportional M. Respectively, A proportional with 1 over m. Yes. Is conclusion. Well, the results of this experiment show that the magnitude of the acceleration is proportional to the magnitude of the force acting on the objects and inversely proportional to the mass of the object. It is described by formula A equals to F over m.